This is video 7 of Unit 9. In this video we'll talk about a few special types of decomposition and then synthesis reactions. So this is the end of the chapter. We've introduced the 5 types of reactions, and here we're going a little deeper into a few of them. So we have 3 types of decompositions. Now these are special in that they do not produce elements. So they don't decompose into elements, which means they decompose into compounds for the most part. And it'll be a little tougher to predict their products, but they'll always decompose into the same type of compound. So for example, if you have a carbonate, remember carbonates are compounds containing this polyatomic ion, CO3. In this case we have calcium carbonate. Carbonates have in them, hidden inside, carbon dioxide gas. That's the way to think about it. And carbon dioxide gas is actually going to leave. So in fact, on the products, that's where you see carbon dioxide gas. Now when you remove a CO2 from calcium carbonate, what's left is just one oxygen and calcium. And that's why you have calcium oxide for your first product. So pretty simple. If you can see, the CO2 was hidden inside of the carbonate, and it was released. And usually it bubbles out. Now this usually requires heat. This will not happen on its own. Actually, all of these require heat. Go ahead and put heat in all of them. And because it will not do this on its own, just by itself. The second type of reaction here are hydroxides. And hydroxides, recall, have this OH polyatomic ion at the back of it. So if we have calcium hydroxide, when we heat it, what happens is, hidden in here is actually a water. The water comes out, and here it is. And if you remove the water out, because here we have OH2, which means we have 2 H's and 2 oxygens, the water here comes out, HOH, and you're left with oxygen. And that's why calcium oxide, again, is the product. You'll see that, you notice the product is the same, the first product is the same on both of these, calcium oxide. The second product, CO2 here, water here. The third type of decomposition is a bit different. It involves a polyatomic ion called chlorate. Now chlorate is this polyatomic ion, ClO3 with a -1 charge. We didn't memorize it as one of the 6, but it is a pretty common polyatomic ion. And what happens when you heat it is, out of here comes oxygen. So out of here leaves the gas oxygen. That's where you see oxygen here. And what's left is KCl. So you really lose all the oxygen. Now you may be saying, how about this 3? There are 3 oxygens, but we only lost 2. Isn't one more oxygen left? No, it is not, because when you balance the equation, you'll see that 2 oxygens, in fact, left. Actually, to be truthful, it's 3 oxygens that left. If you put a 2 here, 6 oxygens left is what happens. So if you balance the equation, you'll see that this comes out. So for a chlorate, the oxygen leaves, and then what's left is potassium chloride. Now in all 3 of these, what will happen is the first element here will change. Instead of calcium, it may be barium, it may be sodium. Instead of potassium, it could be magnesium. So you can change the metal, essentially. This portion right here will change, and then that will simply change this product, the first product. The rest of it will be the same. And we'll do a few examples to show you. These are special types of decomposition reactions. Let's also talk about a few special types of synthesis reactions. And what you'll see here is these are actually the opposite of the decomposition reactions we've just seen. For example, we saw a calcium hydroxide decomposing into calcium oxide and water. Well, it turns out the opposite can happen. You could take calcium oxide, put it with water, and it'll form calcium hydroxide. So this is really just the opposite of the previous example. Now, this one, however, is also pretty similar, except this will be dealing with acids. The second one, if you recall, we had a carbonate that decomposed into carbon dioxide and some kind of metal oxide. Well, in this case, we have carbonic acid. So we do have a carbonate, but the metal is replaced by hydrogen. And this is really a case of carbon dioxide gas reacting with water and combining. Again, this is all synthesis. So what you're doing is you're combining these two, and as you combine them, if you put this one on top of this one, essentially you get yourself 2 hydrogens, 3 oxygens, and a carbon. And that's exactly what you see. 2 hydrogens, 3 oxygens, and a carbon. So you're really putting them on top of each other. You actually did the same thing here. You put them on top of each other. If you stick the oxygen here, you get 2 oxygens, 2 hydrogens, and a calcium. 2 oxygens, 2 hydrogens, and a calcium. So really you're just putting the elements, the compounds, putting it all together, but you can't just put it together like this, CaOH2O, because this is not the compound. What you have to recognize is that between these, hydroxide is formed. When you put these two together, between, same thing here, you can't just say CO2H2O. Between these, a CO3 is formed right here. And that's what you have to recognize. So these are synthesis. Now, the first one of here, this is a metal oxide. This was why it's called a metal oxide. A metal with oxygen in it. When you put it into water, it forms a hydroxide. These are called bases. We've recognized bases before when we did acid-base neutralization reactions. So you get a base, very important. When you put water with a non-metal oxide, this is CO2, a non-metal oxide. Now we could put in here another non-metal oxide like SO2, for example, and it'll form an acid, the same type of acid. And really what you're doing is you're putting the non-metal oxide on top of the water. You're putting the metal oxide on top of the water. And that's how you're forming acids, that's how you're forming bases. So really, this is a lesson in the formation of acids and the formation of bases. This one's a little more complex. Let's see if we can make sense of them on the example problems here. So here's what we've got. We have 2 decomposition reactions up here, and we have 2 synthesis reactions down here. So we said that carbonates will decompose into carbon dioxide gas. So you have a carbonate, carbon dioxide gas will come out of it. Now what's left is going to be the oxide of that metal. So in this case, copper oxide, like this. Now the reason I know copper is a +2 charge is because copper was a +2 charge on the left. That's why I have CuO. Remember that Cu is +2, O is -2. That's why I need one of each. So for carbon dioxide, you don't have to think about balancing charges, but for the metal oxide, because it's an ionic compound, you have to think about balancing charges. The next one, very similar. We have a hydroxide decomposing, and remember we said that this releases water. So water is released. And then you have left the metal oxide. In this case, you have to make sure you write Na2O. Since sodium, recall, has a +1 charge, oxygen has a -2 charge. You need 2 sodiums for every oxygen. So in this case, we have to do that. Now, because we've doubled it up, we must balance the equation now. So we need a 2 in front of here, and that should do it. Okay, the last 2 are actually synthesis reactions. One of them will form an acid, one of them will form a base. Which do you think will form the acid, the non-metal or the metal? Well, it turns out the non-metals form acids, the metals form bases. So this will form a base, and this will form an acid. So simply put these together, put them on top of each other, and in this case, SO2 with H2O will have 3 oxygens now, and an S and 2 hydrogens. So this will be your acid that forms H2SO3. Notice I simply put one on top of the other, but I arranged it so it looks like an acid with a polyatomic ion at the end. The metallic oxides will combine with water to form bases. So you'll form a base, remember, is something that has OH at the end of it, and so you'll have something hydroxide. It'll be the metal hydroxide, sodium hydroxide. So you'll have NaOH. This one's a little more tricky because you can't really see. You still put the one on top of the other, but then what you do is you form 2 of each, essentially. So that's why you have 2 sodiums, you have 2 oxygens, 2 hydrogens. So you'll have to balance it to form 2 sodiums, 2 oxygens, 2 hydrogens. And this is how you write these special types of decomposition and synthesis reactions. Now these were a bit tougher, a little harder to see, and most of these will actually be on the bonus side of the test when we find them. So still go ahead and try a few of your own. Try following these rules, just doing a decomposition, magnesium hydroxide, and a synthesis, magnesium oxide. And we will review these in class.